All right, here's our lesson on 3.3 and 3.4. We're going to talk about modeling and graphing functions. So if you remember from yesterday, functions mean that each input has exactly one output. And there's something called function notation, which I think you've seen before. And function notation, instead of using y, so instead of having an equation that would say like y equals 2x plus 5, all right, that's standard notation. Function notation instead is going to read f of x equals 2x plus 5. And what that literally means is that a function in terms of x, so whatever's inside of here, that's just a way for them to tell you what variable you're using. So that means my variable is x, so a function in terms of x, and then they're going to give you the expression that it's equal to. Okay, so you may just want to make a note that this is function notation. It is read as f of x, or whatever's inside there, and this is just saying a function in terms of whatever variable they are telling you to use. Function notation is used when you're going to be evaluating functions or plugging values in, and we'll talk about that a little bit more as we get into our lesson. All right, so modeling using function notation. So we're just going to do example 1 here. And it tells us we're going to kind of ignore some of the directions. So it says identify independent and dependent variables. That's kind of irrelevant. Like we could talk about that, but that's not a good use of our time. Write an equation for each situation. So first of all, write an equation, right? That means we need an equal sign. Then use it to solve the problem. So this is going to be a lot like what you've done before. So you notice it's going to say a fee of $180 per hour. Remember, per is a rate word. And then how much does he charge for 5 hours? So the first part is just to write, which means I'm going to kind of ignore the question for a minute, and I'm just going to focus right here on writing the equation. So this first part is just to write it, and it's going to tell me about a total. That's what I'm curious about. I'm not comparing anything here. But since they don't tell me the total, I call the total f of x. Okay, so this is going to be my total. My total is f of x equals, and it's $180 per hour, so that's just 180x. There's no additional numbers that you're going to add for this. And then it says, how much does the lawyer charge for 5 hours? So in your notes, I would label down that this right here is you just writing the equation. Writing equation. And then to use it to solve with function notation, so now we're going to solve, and I'll do that in a different color. To solve, it says, what is he going to charge for 5 hours? Well, x stood for the number of hours. And we probably should have said that x stands for the number of hours. We know that because it says per hour. So when we solve, they're saying x is 5. So we write that as f of 5 equals 180, and instead of x now, they're telling me to use 5 for x. So notice that I'm plugging that in 2 places. Once here in my function statement, and then once into the actual equation itself. So it's going to be 180 times 5. And when you work that out, we should get 900. So f of 5 equals 900. And then you are probably going to need to get in the habit of saying what this means. And so the meaning behind this answer for solving is that for 5 hours, he charges $900. Okay, this example is very similar, so I'm going to go really quickly through the writing part because that's what it tells me to do. And then it says state the domain and range. So when I write, Manuel has already sold $20 worth of tickets, already sold $20. He has 4 tickets left to sell at $2.50 per ticket. All right, so $2.50 per ticket, there's my rate. And then $20 worth of tickets, that's something that he's already sold. So I'm going to write f of x equals $20 sold plus $2.50 per ticket, where x is the number of tickets. All right, now when we say domain and range, they are telling me he has 4 tickets left to sell. Well, Well, X are my ticket values, so that means my domain, right? My domain are, and this is just the context here, domain is the number of tickets. And if he only has 4 left to sell, he could either sell 4 or only 3 or 2 or 1, or really he could sell none. All right, well, if we use those domains, we want to figure out how much money he could collect. So my range then is the money collected. And if he sold 4 tickets, then that would be $20 plus $2.50. And I'll actually work backwards. This might be confusing. If he sells 0 tickets, so I'll work backwards. If he sells 0, then he's only made $20. If he sells 1 more ticket, he makes $22.50. If he sells 2 more tickets, he makes $25. If he sells 3 tickets, he's going to make, let's see, $27.50. If he sells 4 tickets, he's going to make, $30. All right, so I kind of worked that backwards, but these would be your reasonable domain and ranges. And this is an example of something that is discrete, because these are like all separate instances. You can't sell like 1 or 2.3 tickets, right? You can only sell 2 or 3, not somewhere in between there. We'll talk about that more if you need some help with that tomorrow. All right, this one is saying to graph the function, and then we're going to do, well, it's really just to graph. So there are 3 parts to being able to graph this. First of all, they give me the domain. They say they only want me to use these values, 0, 3, 6, and 9. Well, I could go plug those in, remember domain or X values, and I could plug those in and solve it every single time. So I could do like 0 plus 3y equals 15, 3 plus 3y equals 15, 6 plus 3y equals 15, or 9 plus 3y equals 15, right? I could plug in this x value every single time, but that means I'm going to have to solve 4 times. And that's a lot. I mean, this is a pretty simple equation, but that's a lot of like the same process over and over again. So those of you that asked, when is some of the literal equations going to be helpful? This is a time that it's going to make sense to solve for the variable before you start plugging in. So I want to solve for y because they give me the x's. So x plus 3y equals 15. If I want y to be by itself. So I'm going to subtract x. That means 3y equals negative x plus 15. And then I'm going to divide by 3. And that's going to give me y equals negative x over 3 plus 5. So there's the equation that I want to use to plug in. That way I'm only going to have to solve really 1 time. All right, then they give me, the reason that they give me these domains, if you notice, is because you're going to have to divide everything by 3. And all of those things are divisible by 3. So if I plug in, I'm going to say y equals, and I think ours makes probably more sense to you, y equals negative 0 divided by 3 plus 5. Well, negative 0 divided by 3, that's just 0 plus 5 is 5. So my answer is going to be 0, 5. Because 0 is what I plugged in, and 5 was what I got. All right, let me do another one with you. Y equals negative 3 over 3 plus 5. That is negative 1 plus 5, which is going to be 4. So here I've got 3, 4. All right, I'll keep going. Negative 6 over 3 plus 5. All right, and that's going to give me negative 2 plus 5, which is 3. So 6, 3. So hopefully you're noticing the pattern of how this is working. Negative 9 over 3 plus 5. That's going to give me negative 3 plus 5, which is positive 2. So 9, 2. All right, all of that was to be able to graph. One other thing I want to tell you about your table, so you should use 3 parts of your table. This last part right here, instead of labeling x and y, I really want you to call those solutions. you'll see why. We're going to get into that a little bit later, but just know that all of those are solutions. And then to graph the ordered pairs, remember we just graph x comma y. So 0, 5. Notice that my graph is counting by 2's, so I got to kind of plot in between here. 3 and 4. 6 and 3. And 9 and 2. All right, so that's what we should have graphed there. All right, and then thinking about our previous question, it says, why do you not connect all the points? And that's because, you don't have to write any of this down necessarily, but the reason they're not connected is because we want only the domain that they gave us. If we connected them, we would be including other values. So how would the graph be different if the domain was between 0 and 9? That means all of these values, not just individual points. And if that were the case, you would take our individual points and they would be connected. It would be continuous for that section. So instead of being discrete, it would be continuous if they wrote it with that inequality. Okay, so this question is asking us to use the graph to be able to solve. So this is just another chance for you to kind of practice using this table. The nice thing here is that the y, like the equation's already solved for y, so it's pretty easy. Now, if you don't know what x values to use, kind of take a peek at the x-axis on our graph. Here they go ahead and tell us, like, whole numbers are probably going to be something that's easy. So I'm just going to go ahead and use 0, 1, 2, and 3. All right, so if I plug 0 in, y equals 15 times 0 plus 5. That gives me 5. So my solution is 0, 5. If I plug in 1, that's 15 plus 1, which is going to be 20. So 1 gives me 20. If I plug in 2, 2 times 15 is 30, plus 5 is 35, so 2, 35. If I plug in 3, 15 times 3 is 45, plus 5 is 50, so 3 is 50. All right, so we're going to take a second to graph those. So we've got 0, 5, and 120, 2, 35, and 3, 50. And the question is, how far will the cruise ship be 2.5 hours from now? So that's going to be perfectly in between 2 and 3 right here. So if I follow up and kind of think about my pattern, to me, it looks like somewhere between 40 and 45 would be my answer. So I'm going to say 42, about 42.5 is how far away. So 42.5 kilometers. And remember, you can write that, the exact notation would actually be to say f of 2.5 equals 42.5.